Hello everyone, welcome back to part 5 of our SWAT full course. In this tutorial, I will show you how to run your SWAT model for future climate scenarios using CMIP6 climate data. After completing calibration and validation, it's time to project how your watershed may behave under future climate conditions. CMIP6 stands for Coupled Model Intercomparison Project Phase 6, and it is the latest coordinated global climate modeling experiment. The World Climate Research Program, they already developed multiple models, CMIP3 and CMIP5, and the recent one is CMIP6. And CMIP6 run under 4 different scenarios. It's called Shared Socioeconomic Busway, SSB 126, SSB 245, and SSB 585. And the most commonly used is SSB 245 and SSB 585. There are many ways to get future climate data. One option is NEX-GDDP dataset. I already have a full tutorial on how to download it, and I will leave the link in the description below. If you haven't downloaded CMIP6 climate data, you can approach the website from here. Write NEX-GDDP, NEX-GDDP, CMIP6. Select the first option and you can download the data from here. NEX-GDDP. Yeah, based on your study area, you can select which model are best fit your study area. You can explore the tutorial on how to download CMIP6 climate data, and I will share the link in the description. As I have already created a tutorial on how to download climate data, so I will not repeat it. I will just show you how to extract the NetCDF into CSV file. And for extracting NetCDF into CSV file, I have created 2 tutorials, one using ArcGIS and another tutorial on Python. But for this tutorial, I'll show you how to extract NetCDF into CSV using RStudio. If you don't have RStudio, you can download it. And I already have RStudio. I'll open it from here. It's loading. This is the RStudio interface, and I will share this code in Google Drive. No need to write it again, but you have to make sure that you active all those library. You have all those library over here and you already activated. First one, right? SF. Yes, it's here. You have to active this one. Okay. And then raster, right? Raster, active raster. And NetCDF, NetCDF4, active NetCDF4, and then SP, yes, already activated. Then active this. Now all library has been activated. And the advantage of using this code, you will list all longitude and latitude to extract all file within your watershed. And here you have the list of all latitude and longitude within your watershed. The first one is name. So those the name of station. You need to change the name of your station based on the number of station in your basins. And then you need to change longitude. This is the longitude for the first station and latitude for the first station, and the second one is the second longitude for the second station and second latitude for the second station. And so you have to make sure you well organized all your latitude and longitude and the name of your station. The name of the station is not important. The most importantly is latitude and longitude. And then from here, you have to change the directory from where your data has been saved. So I'll show you where my data saved. the data is saved here. Click here and copy the bus. Copy, paste here, and change this. Change this. Here you have starting date of your data. Check the starting date of my data, 2026. 2026, and ending date 2038. 38. Then you have to change this one. This the NetCDF file. Copy the NetCDF file name. Click here and copy the name up to here. Don't copy the year. Copy. Changes is the same. And then we have year and .nc. We haven't copy the year, but we add year over here. Will start with the first year, which is 2026, and then for each iteration we'll add one. For the next step, we'll go to 2027, then 2028 until the end year of your data. And then you have to specify the output location of your CSV file. I want to save it in the same directory. Copy here, copy, and paste it here. Then change it, and this as well. And here type whatever name you want plus .csv. If this is the first time to use RStudio, SF will not be as default in your package library. So you need to install it using this command. Here, delete this hash, run this command. I already installed it. It will start installing the package. Okay, then the input hash. Now everything is set correctly. Then we have to run the code. Here, run. Yes, start extracting, starting by 2026, and then it will go to 2027, then 2028 until the end of your data. In my case, for the tutorial purpose, I download a few data to show you how to extract the data in RStudio. But I already prepared the data for climate in the format that SWAT model can understand, and I'll show you after downloading. Data downloading done. Yes, this is a CSV file. This is a 22 station I located, and station 1 is represent the first latitude and longitude in your code, and the second station is represent the second latitude and longitude in your code. To ensure that your data is well extracted, you can insert one column here, insert, and type date. Zero one 2026. Enter. Drag it down. and our data is up to 2038. Is December 31st, 2038. And the precipitation is saved in kilogram per meter square per second, and we need to convert it to millimeter per day. To convert the data from kilometer per meter square per second to millimeter per day, we need to multiply this data by 860,400. For example, for the first station, we need to multiply the first one by this number and make this constant. Yes, is enter. This is the precipitation for this column. I do it to only one column, but you can do it to the rest of the column. Now we know how to extract the data from NetCDF to CSV. Then we need to prepare this data in format that SWAT can understand. If you don't know how to use RStudio, I have already made a tutorial in ArcGIS and Python. And you can use the same code to download the data for the temperature max and temperature minimum and other meteorological variable. And you have to make sure that to check the unit of each variable from this website, from the main website of the NetCDF. Check this one. Take one if you download the data for the version 1 or version 2. The documentation from here, scroll down, you will find all information are listed here. For example, we download precipitation are saved in kilogram per meter square per second, and relative humidity in percentage, wind speed, and all variable are listed here. Close this one. Close this one. The next step is to prepare the data for SWAT model. Okay, go back. Go to CMIP6. This is the data I already prepared for the future climate. The first folder is start from 2020 to 2049, and the second folder is start from 2050 to 2079, and the last folder is from 2080 to 2100. And it's up to you if you want to run SWAT for the entire duration from 2020 or from 2026 to 2100. And let's open. I prepared the precipitation. If you don't know how to prepare the precipitation and temperature and other variable, you can check the part 1. I have explained how to prepare the data for SWAT model in the first part. Open this one. Yes, here. This is the main file where we have all locations. Here the number of station we have, and same for temperature. This is a patch file where we have all locations and the station with maximum and minimum temperature starting from 2020 to 2049. Now open SWAT model and reuse the meteorological data. Here, go to the right input table, select right input table, select weather station. Here in weather generate data, select user, rainfall, rain gauge. Go to where your data are saved, CMIP6, climate, precipitation, yes. UCP part. Okay. Go to temperature, climate station. Go back, temperature, patch. Okay. And you can download for wind speed, solar radiation, relative humidity. But in my case, I will just use rainfall temperature as the most influence variable in my basins. In your case, you can add other variable and say okay. Process complete. Okay. It's ready. Cancel. Go to next step. Write input table. Okay. Select all. Create table. Yes. Okay. Yes. And wait until all turn into green. Okay, done. Cancel. Database update. Okay. Update. Done. Make sure that don't change anything in HRUs. You only change input table and go to SWAT simulation. Before you run SWAT, you need to adjust the parameter in the manual calibration helper using the best parameter you get from the calibration part. Here, let's start with the CN, and here let's open SWAT cup. Yes, yes. Okay, open. Go to E. In E, SWAT 2011 scenario, manual 2, M. Okay. Okay, select iteration history. As I show you in the previous tutorial, I have multiple iteration. This is the best calibration I have. Go to calibration output. In calibration output, go to best parameter. I have to feed those information back to the model. Let's start with CN. Open any Excel file. Copy this value. Paste it here. Equal 1. This value. Enter. This value will be multiplied to CN. Copy. Here. CN multiplied by all, 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 all. Update parameter. Okay. Then the second variable is alpha BF. Alpha BF. Copy. Alpha base flow. Alpha base flow. As I mentioned before, V means you have to replace the default parameter with the value is showing here. Replace, change to replace the value and replace it. R means you relatively adjust the default parameter by multiplying it. All, 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 update. Okay. Next parameter is groundwater delay, V. We have to replace, copy. No calculation will be done. Groundwater delay. Replace. Yes. Okay. Okay. All, all, all. Update. Okay. Next parameter is groundwater QMN. Copy. Replace. Yes. Groundwater QMN. Replace. Replace the value. All, 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 all. Next is CanMax. Copy. But here CanMax is relative. Here equal 1 plus the value. Enter. Yes. Copy. Here CanMax. Yes. Multiply by the value. All, all, all. Update. Okay. Next is relative. Also, we have to do same calculation, but I can paste the value here. Yes. See? Isco multiply. Yes. All, 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 all. Last one is also relative groundwater reverb. Copy. Paste here. It's calculated. Copy. Yes. Okay. Multiply by best. All, all. Update. Now we done with the manual calibration helper. Close. So let's close this one and close Excel. Don't save. Go to run SWAT. The data is already updated starting from 2020 to 2049, and you can select which output you want. Print snow. I don't have snow in my stations. I don't want hourly data output. It is up to you which type of data you want to be print. Soil. Okay. Depth. Storage. Best site. Yes. And then skip 3 years as a warm up and set up SWAT run. Okay, run SWAT. Okay, I will pause the video to save some time. Okay, done. Run successfully. Okay, close this one. SWAT simulation. Read SWAT output. I'll select reach, sub, and HRU. It is up to you to select what type of output need to be print in your output main file. Then input file database. Yes, done. Okay. Right here. Sim 2. Save. Okay, saved. SWAT check. Then in output, locate where your file saved. Sim to text in out. Okay. Examine the result. Then all information are listed over here. You can check the hydrology, sediment, nitrogen. You have different result here. Okay. Cancel. Cancel this one. Okay. Go to scenario. Scenario sim 2. This is the last one we have done. Table out. SWAT output. Enable content. Go to reach. This is the result. This is the result of your model. Start from 2023 and end up. Yes, here. Yes, 2049. You can extract the different variable you want here. Flow in, flow out, evaporation. You have sediment output and different variables here. You can check out this file and have some understanding. This is how to run your model for future climate using CMIP6 data. If you found this tutorial is helpful, like, share, and subscribe. If you have any question, leave it in comment below. See you next tutorial.